Why do jets create sonic booms? Physics of sound. Imagine flying faster than the speed of sound and suddenly hearing a loud crack that echoes across the sky. What causes that incredible noise? Let's find out. When an aircraft moves through the air, it creates sound waves that spread out in all directions. These waves are tiny vibrations traveling through the air, reaching our ears as sound. Normally, these waves move smoothly ahead of the plane if it's flying slower than the speed of sound, about 343 meters per second at sea level. But when the jet speeds up and hits or exceeds this speed, things change dramatically. The aircraft starts to catch up to the sound waves it produces, compressing them into a tight bundle. This compression forms a shock wave, a sudden jump in air pressure that travels behind the jet in a cone shape. When this shock wave reaches the ground, it's heard as a sonic boom. Think of it like a crack of thunder after lightning, but in the sky. As the jet approaches the speed of sound, the sound waves in front of it bunch up, increasing in frequency and loudness. When the jet finally surpasses the speed of sound, it can no longer push the sound waves ahead of it. Instead, it leaves behind a continuous shock wave that trails behind. This shock wave is what causes the loud boom we hear. The size and shape of the aircraft influence how strong the shock wave is. Larger jets push more air and produce louder booms. The altitude also matters because higher flying jets spread out the shock wave more before it reaches the ground, making the boom less intense. This phenomenon is connected to the Doppler effect, which explains how sound frequency changes when the source moves relative to us. When a jet moves faster than sound, the waves pile up, creating that distinctive boom. In everyday terms, it's like the thunder you hear during a storm, but caused by a jet breaking the sound barrier. The sonic boom isn't just a one-time event but continues as long as the jet stays supersonic, creating a trail of noise behind it. Understanding how this works helps engineers design aircraft that produce less disruptive booms. They work on shaping the aircraft to change how shock waves form, aiming for quieter supersonic travel in the future. So, in simple words, jets create sonic booms because moving faster than sound compresses air into shock waves, producing that powerful, explosive noise we hear. It's all about the physics of sound waves and how they behave when objects break the sound barrier.